Who the wild things are, what or who awaits us at the edge of exploration, by Jeff Stepp, read by Rod Pyle. As early explorers like Magellan, Coupe, a legendary Polynesian explorer, or even the Papar, very early Irish explorers, set sail into the open ocean, they all expected to find something fairly obvious, a rumored new world or perhaps the edge of the old one. Less obvious, however, is who they might have expected to find. What sort of unknown people, flora, and fauna awaited them past the crude borders of their maps? Today, as the discovery of new exoplanets and the ensuing arguments over biosignatures proliferate, one can't help but wonder what or who might be found at the edges of our own stellar sea. To answer that question requires a leap of faith not unlike that required by those early explorers, or any seeker of knowledge. Compare our current understanding of exoplanets and potential extraterrestrial life to the early days of the discovery of the cell. In the late 17th century, when Antoine van Leeuwenhoek first observed rainwater under crude magnification, it was clear that something was there. But with regard to what it was, where it came from, or what it might do, he had no idea. Over time, the ensuing efforts by him and other scientists revealed not only the cell, but also its complex inner machinery. This landmark journey was, in essence, the same one we embark on today, starting with exoplanet spectroscopy. Whether we experience as much success with our understanding of distant planets as we did with unraveling cell biology remains to be seen, but the effort is underway, and it starts not with observing that which can't be seen directly, like extraterrestrial life, but instead by looking for patterns based on what can be seen, such as life on Earth. In a recent interview, Dr. Eric Kirschenbaum, a zoologist and astrobiologist from the University of Cambridge and author of The Zoologist's Guide to the Galaxy, says that he devotes much of his research to terrestrial science, studying the way various species, particularly wolves and dolphins, communicate and how their evolution contributes to the various communication patterns and methods they employ. Kirschenbaum also applies his terrestrial studies to the burgeoning science of xenobiology, the biology of species not yet known, and in this context, species alien to Earth. Quote, "We can't know the details of what alien life will look like," Kirschenbaum begins, "but we can make predictions about what it will be like from looking at life on Earth. There are certain rules of biology, just like there are rules of chemistry and rules of physics that apply throughout the universe. On any planet that has complex life, there must be predators, and there must be prey. Since all life needs energy, all life competes for energy. Therefore, some life will try and eat others to get their energy," he says. Whether that energy comes from unknown sources isn't very important at this stage of exploration. According to Kirschenbaum, any planet with complex life must necessarily have a complex ecosystem as well. He says, quote, "Complex organisms don't evolve for no reason. They evolve because of the complex interactions between different kinds of organisms. So if we find a planet with complex life on it, we know there will be a diversity of different kinds of organisms," he says. Quote, "There will be the alien equivalent of plants that gain energy from their sun, and there will be the alien equivalent of animals that move around to eat plants or other animals. It's one of the reasons you don't find little green men on Mars. There's nothing on the planet that could support such complexity. On Earth, unless you are a single-celled organism that can asexually produce, there's really no such thing as being alone. Cooperation and competition, and symbiosis and parasitism are just two of the dichotomies that interact in a life-rich environment." Quote, "It turns out that evolution dictates certain features of life that we would expect to find everywhere," Kirschenbaum says. "It dictates how much you cooperate and how much you compete with other individuals of the same species or of different species. These are all things we understand very well from Earth, and they'll apply on other planets as well," Kirschenbaum adds. In his estimation, whatever life exists will likely behave similarly to the way life on Earth does, residing in a complex ecosystem and competing for resources. Crucially, it won't do this alone. It's the idea of social interaction, where it comes from and what it means, that's at the heart of Kirschenbaum's work, because a complex enough species will necessarily develop some means of communication, both for use amongst its own species and possibly externally with others. This does not necessarily mean that communication will take the form of language, Kirschenbaum notes. Quote, "For decades, if not centuries, humans have tried to understand whether there are any other animals that have a language. In recent scientific research, we've tried to investigate whether there are any other species that use language, and we haven't found any yet." Quote, there are some species, dolphins for instance, that have a very complex communication system, and we really don't understand what they're saying, Kirschenbaum explains. But they don't appear to be saying distinct, discrete ideas like we would when we communicate in language. Experiments with some chimpanzees and bonobos have shown that they can understand some of what language is, but they don't seem to use it in the wild. It seems to be a cognitive ability that they have, but is not used for language, Kirschenbaum adds. He suspects there's a basic evolutionary reason for this. Quote, everything is a trade-off in evolution. There's a huge advantage to language, but there's also a huge cost, the brain. It's an easy enough idea to get behind. To understand and utilize language, one needs a complex brain, a skull large enough to fit it in, and lots of energy and blood to operate it. All this comes at a cost, and so far it appears no animal species in the world, apart from humans, has paid the price, quite simply because they haven't needed to. Their current method of communication works just fine. So if one day we find intelligent life, will it be able to talk to us at all? And if they don't have a language, will it be possible to ascertain what they're communicating, or if they're even attempting to do so? Yes, Kirschenbaum says. What's amazing is that on Earth we have examples of almost every form of communication that's possible. The way the animals communicate is tightly constrained by physics. You can communicate by sight, by sound, by smell, and by electricity. And that's basically it. So we can study those forms of communication here on Earth and then use those to interpret what we expect to find on other planets, Kirschenbaum says. With all this talk of complexity, Kirschenbaum doesn't believe human and extraterrestrial dialogue is in the near future. Quote, when you teach your children a language, you point to a dog and say dog. We can't do that with aliens, he explains. One of the ways to get around that is to try and create messages that are universally understandable and universally intelligible. We create messages where the context makes it clear what the nature of our language is and what messages we're trying to convey. There are always ways of sending information that we think should be intelligible. In other words, keep it simple, stupid. Kirschenbaum adds, for some reason it took a long time for language to evolve on Earth despite the fact that all animals communicate. Clearly there are some constraints on what kind of communication can evolve into language, and that's likely to be the same on other planets as well. I'm sure that on any planet with complex life there will be a diversity of life, but language itself is likely to be rare, though perhaps not totally absent. Additionally, how this language functions may be wildly different than on Earth. Quote, we don't know how life works on other planets, Kirschenbaum says. We know that plants on Earth are green because of the particular chemicals they use to capture sunlight, but the chemistry of life on other planets may be completely different. Gravity, atmospheric gases, temperature, and even what type of star the planet orbits, all these things will influence what an alien creature will look like and therefore how it will communicate. But it will surely communicate somehow, he adds. Of course, Kirschenbaum acknowledges that the day any of this becomes possible is far in the future. Quote, there are huge challenges to traveling between stars, and we don't even conceive of the technology that would allow us to go to the planets in another star system. So when scientists like me think about studying alien life, we know we're never going to go there. We're never going to go and observe the alien animals like we would observe animals on Earth. It's simply too far away. We somehow need to find technologies and means of understanding what life is like on another planet while we remain in our own solar system, he says. In short, any direct communication between us and an alien species is likely to occur by our descendants many generations removed. One does have to wonder then, is the whole question of what or who aliens might be a moot one? Should we not even bother working on the answer, if it's likely to be a century or more in the future? Well, imagine if the earliest people hadn't left their tribal homes, or the earliest explorers had not set out to an unknown sea. What or who would we be today? Would we have had the sense or even the opportunity to peer into a tiny drop of rainwater in order to one day discover the fundamental architecture of life? The idea of a spacefaring civilization may be built on ambition, but it's powered by the gradual, tireless cultivation of knowledge, even that which, at this moment in time, seems unattainable.
Welcome. My name is Gabriel Rothblatt, and I am the chair for the International Space Development Conference in 2025, Together Beyond, being held at the Rosen Center in Orlando, June 19th through 22nd, 2025. I hope you will join us there at Astra.